Ocean Labs. Deep ideas. Simple knowledge.
So, let's talk about something that sounds, well, impossible. Can the ocean, the entire ocean, actually run out of oxygen? It sounds like something straight out of a sci-fi movie, right? But the thing is, it's becoming a shockingly real question. So yeah, let's dive in. I mean, really, just take a second and picture it. That huge blue engine that covers most of our planet, what if it just stopped breathing? The consequences? They're beyond what we can even wrap our heads around. Boof. Gone. The entire foundation of life in the sea would just crumple. You're talking everything. The tiniest plankton, the biggest whales, all of it. The whole underwater world we think we know would just vanish. And seriously, that's not me being dramatic. The ocean is where life on this planet got its start. A breathless ocean, that's a total system failure for all of us. So how does this whole thing even work? How does the ocean breathe? Yeah, you heard that right. The ocean breathes. Obviously not with lungs like we do, but it has this constant exchange of gases that keeps it alive and kicking. So where does all that oxygen come from? Okay, so it comes from two main places. First, you've got these tiny microscopic powerhouses called plankton. They're basically doing photosynthesis, just like trees and plants do on land, and they pump out a ton of oxygen. The second source, it's the atmosphere itself. Oxygen from the air literally mixes into the surface of the water, especially when it's all windy and choppy. It's that 1-2 punch that keeps the ocean full of life. And this really gets to the heart of it, doesn't it? It's an incredibly delicate balance. We're talking about a system where even a tiny dip in oxygen can cause chaos, and fast. Everything from the smallest shrimp to the biggest whales, they're all living on a razor's edge. Okay, so this isn't some far-off what-if scenario. Nope, the warning signs are here right now. They have a name that's, well, it's pretty blunt. They're called dead zones. And believe me, they live up to the name. So what is a dead zone? Think of it like a patch of the ocean that's literally suffocated. The oxygen levels get so incredibly low that anything that can swim, like fish or crabs, gets out of there fast. Anything that can't, dies. It becomes a barren, underwater desert. And how this happens is a pretty wild chain reaction. It actually starts on land. You've got all these excess nutrients, like from farm fertilizer, that run off into the rivers and out to sea. This stuff is like superfood for algae, causing this massive, out-of-control bloom. But then all that algae dies, sinks to the bottom, and that's when the bacteria show up. They have a feast decomposing all that dead stuff. The problem is, this bacterial feast uses up, you guessed it, all the available oxygen in the water. And we're not talking about little puddles here. Take the Gulf of Mexico. It has one of the biggest dead zones in the world. At its peak, it can be the size of the state of New Jersey, all fueled by runoff coming down the Mississippi. It's a massive, real-world example of this exact process playing out. So you might be thinking these dead zones are just a local pollution problem, and they are. But they're also a symptom of something much, much bigger, a global trend. And this is where we have to start talking about climate change. Scientists have a name for it. It's called ocean deoxygenation. It's exactly what it sounds like. On a global scale, the average amount of oxygen in the ocean is going down. And the scary part, scientists are seeing this trend speed up. So why is this happening on a global scale? It's a two-part problem, really, tied to warming. First, it's just basic physics. Think of a warm soda versus a cold one. The warm one goes flat faster, right? Same idea. Warmer water just can't hold on to as much dissolved gas, and that includes oxygen. But there's a second piece to this puzzle. As the surface water gets warmer, it becomes less dense, and it basically forms a cap, or a lid, on the ocean. This lid stops the natural mixing that would normally bring that oxygen-rich surface water down into the deep. And here's where things get really chilling. This isn't a new script for our planet. We've seen this movie before. Earth's history has a pretty stark warning for us about what happens when the ocean's oxygen disappears. Let's turn the clock way, way back. We're talking 250 million years ago. There was an event that scientists call the Great Dying. And it's not an exaggeration. It was, hands down, the worst mass extinction this planet has ever seen. Just look at this number, 90%. 90% of all life in the sea, gone, wiped out. It was basically a hard reset for the oceans. For years, the big question for scientists was, how? What could possibly do that? And this is the punchline. The geological record is pretty clear. The trigger was a period of rapid global warming, probably kicked off by massive volcanic activity. That warming created a stagnant, suffocating ocean, an ocean that couldn't support life. Does that sound a little familiar? So when you see that echo from our planet's deep past, it forces you to look at today and ask the hard questions. What happens next? What does this low oxygen future actually look like for our seas? See, the thing is, the ocean doesn't have to hit 0% oxygen to be a disaster. Not even close. Even small drops can lead to huge fish kills. It can cause entire food chains to just fall apart. It's what kills vibrant coral reefs, and of course, it puts the global seafood supply that billions of us depend on in serious jeopardy. So that brings us right back to where we started, the big question. After all this, the science, the modern dead zones, the terrifying look into the past, can the ocean actually run out of oxygen? Well, the short answer is probably not completely. The ocean is just so huge, and those processes that put oxygen in are so powerful, a total planet-wide shutdown is, well, it's pretty unlikely. But, and this is a huge but, that's not really the right question, because this is the key. The whole ocean doesn't have to die for it to be a catastrophe. Huge parts of it can run out of oxygen. These dead zones, they're getting bigger. They're spreading. We're creating these vast, silent, breathless patches in the sea where life just can't exist. So, in the end, the question isn't, will the entire ocean suffocate? The real question is, what kind of ocean are we choosing to have? Is it one that's full of life everywhere? Or is it an ocean pockmarked with these vast, silent, dead spaces? Because the answer to that question, well, it's up to us, and we're deciding it right now.